Alright guys, we're going to be solving another question from the second chapter of the Mechanics of Materials by Johnston. And in this one we have this rod BD that is made of steel. We have the elastic modulus for this rod and it's used to brace the axially compressed member ABC. And we know that the maximum force developed by the member BD is 0.02 P. We have the P 130 kips. So we have the force in the member BD. It's basically 2% of the force P. And we know that the stress must not exceed 18 KSI and the maximum change in the length of BD must not exceed 0.001. So we have two conditions. We have to watch for the stress and also the formation of the member BD. And at the end, we need to determine the smallest diameter rod that can be used for member BD. So as I mentioned, we can easily find the forcing member FBD. Forcing the member BD, we know FBD is 0.02 times P, which is 130 kips. This is going to give us 2.6 kips, or if you want to report it as pounds, you just have to multiply by 1000, so basically 2.6 times 10 to the 3 pounds. So we have the force in the member BD, and let's just go with our stress condition that we have. We know that the maximum of the stress in member BD should be 18, so our FBD is equal or less than 18 KSI. So since we are looking for the smallest diameter, we have to go with the 18 because our stress is equal to the force in BD over the area. Since area is in the denominator, the lower we get area, the higher we get the stress. So if you want to find, since the question is asking for the smallest diameter rod, and we know area is I divided by 4 times d squared. So since we are looking for the smallest diameter, therefore we are looking for the smallest area, which means the highest stress, which is going to be 18 KSI. So we can find the area pretty easy in here. It will be the force in BD 2.6 times 10 to the 3 divided by the stress. The stress is also in KSI units, so we can just keep KSI, but since I wrote the force in pound, I'm going to do the same for stress 2. So pound per inch squared or PSI, and this will be pound, or just go with everything with KSI. So this is going to give us the area, and we know this will be equal to pi divided by 4 times d squared, but let's just find the area for now. We'll find the diameter later. So basically we have 2.6 divided by 18. 2.6 divided by 18, that's going to give us 0.14 for repeating. So this will be inches squared. So that was based on the stress condition, and let's just go based on our deformation. So for the deformation, we know the maximum change in length must not exceed 0.001 times the length of ABC. The length of ABC is basically 72 plus 72, which is 144. So our deformation here would be 0.001 times the length, which was 144. So this is going to give us 0.144 inch as our deformation, and we have our formula. Deformation is equal to force times length divided by a, or area times elastic modulus. I explained this in the previous videos. Feel free to check out the playlist for the questions in this chapter. I'll explain where this is coming from. And since this will be the deformation in BD, we're going to deal with the force in BD and also the length of BD. So the force will be what we found in the previous step, 2.6 times 10 to the 3 pound. So the length of BD would be this length, which we know is 54 inches. The area is what the question is asking, and we have the elastic modulus at the beginning of this 29 times 10 to the 6. And you just have to watch for the unit. This is PSI, or pound per inch squared. So you have to go everything with pound. So that's why I did the 10 to the 3 for the force, because it was 2.6. And this will be equal to 0.144 inch. And we can easily find our area, which would be 2.6 times 10 to the 3 times 54, and in the denominator we have 29 times 10 to the 6 times 0.144, and our area here would be 0.0336 inches squared. And now we found two different areas based on this, and the question is that which one would be acceptable for us, and based on that we can find the diameter, because that's what the question is asking. You might say, since the question is asking for the smallest diameter, we have to go with the smallest area in here. So between these two numbers, 0.144 and 0.0336, we're gonna go with this one, but we cannot do that. We actually have to go with the larger area. And the reason is that if we go with the smallest area, that area in here is gonna give us a stress more than 18, which is gonna fail the system. So this time we actually have to go with the area that is largest. So we're gonna go with the first answer, or 0.144. And as I said, area would be pi over 4 times d squared. So if we just want to find d, we simply have 4a divided by pi, and we're just going to do a square root to get rid of the power of 2. So our d would be the square root of 4 times a, 144 divided by pi, and this should give us the final answer, square root of 4 times 0.144 divided by pi, and this will be the final answer, 0.428. And yeah, that's pretty much everything for this one. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.